Hello everyone, this is Pankaj and I welcome you all to New Day, New Question series. So once again we have one more question on the series. Let's see what this question is saying to us. Basically the question is saying two identical charged spheres are suspended by the strings of a equal length. The string makes an angle of 37 degree with each other when suspended in a liquid of density 0.7 gram per centimeter cube. Angle is still remains the same. Density of material of the sphere is 1.4 gram per centimeter cube. They are asking us to find the dielectric constant of the liquid. So basically in this question what is happening, like we have two identical charged spheres. So let's draw their diagram. Suppose this is the support we have from where your two spheres are being separated. I will take this as a reference line and I will try to draw the diagram of the two spheres. So this is the first sphere we have and this one is basically the second sphere we have. So let's say this is the first sphere, this is the second sphere we have. Of course they have some charge, so I'm going to write the charge on the first one as a q. Of course they will also have the mass, so mass I'm going to take as a m. So charge, because they have said that identical, so mass and charges will be same. So charge is basically q and mass is your m. So let me write it at like this side, q and m. This one is also q and m. One more thing which I am taking is distance between these two spheres. So let's assume the distance between these two spheres as a d. You can take small d, capital D, whichever you want. Okay, so this is our distance between the two spheres. Now what they have given, they have given the angle between the two sphere, like two strings, as a 37 degree. But right now for the reference purpose I'm not going to use 37, I'm just going to use theta wherever I will need, if I will use that angle, basically 37 degree. Okay, so what we have here, this will act as our reference line. Now here we have this reference line. Angle will be, if this one is theta, this one will also become equal to theta. This angle will again become equals to theta. Now one more thing, like we have mass, so mg will act in the downward direction, as we know that both the spheres have same charge, so there will be the repulsion. Because of that repulsion there will be electrostatic force Fe, and along this we will be having basically tension T. Now we can see that tension will have two components, one will be your T cos theta, one will be your T sin theta. So along this side we will be having T sin of theta, along this side we will be having T cos of theta. Now when I will try to write the equation, I can write that T sin of theta is equals to Fe, which is your electrostatic force, equation number 1, and second one is your T cos of theta, which will be equals to mg. This will be equation number 2. Let's take the ratio. So equation 1 divided by equation 2. Your t and t will get cancelled out. Sin theta by cos theta will be tan theta, which will be equals to Fe by mg. F is standing for the electrostatic force. Now this is the first case we have. Now what is happening after this? Just 1 minute. After this we are taking the complete setup inside the liquid. So after this what we are doing, we are basically taking the complete setup inside the liquid, and what they have given, basically liquid whose density is 0.7 centimeter cube. Okay, entire setup is suspended in a liquid of density 0.7 gram per centimeter cube. Now which things will change once I will change the medium? So listen, Diagram will be same as it is. I'm going to use the same diagram. We will need this because there are certain things which I need to change. So I will just copy this diagram so that I can redraw and show which things will change. Now this setup is now taken into the liquid, and when we have taken this system into the liquid, we know that basically there will be one more force which will act, and that force is basically your buoyant force. So buoyant force always act like in the opposite direction of the weight, that is mg. So I'm going to write here buoyant force. Let's use some other color so we can see properly. Buoyant force, whose formula is basically volume V rho into G. Now finally, if we try to find this, let's see what will happen. Now our new equations will become, first thing is again T sine theta, which will be equals to F E dash. This time I am writing it as a F E dash because we know that dielectric constant is changing, and as the medium changes, electrostatic force also changes. So T sine theta I am taking as a F E dash. Second one, T cos of theta. It will be basically difference of mg and v rho g. Mg like mass, which is volume into density. Volume density of sphere is sigma into g. V sigma g and v rho g. Difference of both terms. Let's take v sigma g common. So after taking v sigma g common, I will be having 1 minus rho by sigma, and this v sigma g is nothing but the mg. So mg into 1 minus rho by sigma. This is the value of T cos theta. Equation number 4 I am naming it. Now I will take the ratio of 3 and 4. So equation 3 divided by equation number 4. Again T and T will get cancelled out. We will be having the tan theta, which will be the ratio of Fe dash upon mg1 minus rho by sigma. Now we can see that in equation number A and equation number B, both have the left hand side same as basically tan theta. So when we have left hand side same, we can equate the right hand side. So from equation A and B. So next is from A and B. So from equation A and B, if we try to write left hand side, we will be having Fe by mg. On right hand side, we will be having Fe dash upon mg 1 minus rho by sigma. Now this mg and mg will get cancelled out. Fe, that is 1 upon 4 pi epsilon naught. Charges are same, q square, distance is d square. F dash will be 1 upon 4 pi epsilon naught will be replaced by, we know that k, that is dielectric constant, it is epsilon of medium by epsilon of free space. So as our medium got changed, instead of epsilon naught I will have to use epsilon m, which is k times of epsilon naught. So k times epsilon naught, again q square by d square. Along with it there will be 1 minus rho by sigma. Now this 1 upon 4 pi epsilon naught, 1 upon 4 pi along with the epsilon naught, it will get cancelled out. q square by d square, q square by d square again got cancelled out. So finally this k I'm going to send here. So after sending that k, we will be having k is equals to 1 upon 1 minus rho by sigma. Let's put the value of rho and sigma. Rho standing for the density of liquid and sigma is standing for the density of solid, that is sphere. So value of rho, that is density of liquid, is 0.7 and solid, that is sphere, is 1.4. So 0.7, then here we will be having 1.4. It will be basically 1 by 2 because decimal and decimal will get cancelled. So 1 minus 1 by 2 will be again 1 by 2. Finally 1 upon 1 by 2 will be 2. So our final answer will be